We are down to the stoichiometry of chemical reactions. Again, stoichiometry is the quantitative study between the relationship of substances undergoing chemical or physical change. Therefore, we can use stoichiometry as a tool to determine the amount of product or products produced from a chemical reaction given the amount of reactants or vice versa. We will use this diagram. So if we are given the mass, we will convert that into moles using the molar mass ratio. Or if we are given already the number of moles, we will start here. An additional step is added aside from the usual conversion. Here you will apply your knowledge in chemical balancing. It's a good practice to always check if the equation given is balanced or not before doing any calculations, because failing to do so will mess up your calculations. So here we will use the balanced chemical equation ratio. In this process, we will be able to convert the amount of a species to another that is also participating in the reaction. So we will get the number of moles. If we are asked to report our answer in moles, we will stop here. If we are asked the mass, we will use the molar mass ratio to get the desired mass. There are two important concepts that I would like to introduce concerning the stoichiometry in chemical reactions. First, the limiting reagent. The limiting reagent is the substance that will be used up first in the reaction. It will be the one to be completely consumed. The limiting reagent dictates the amount of product that will be produced, the theoretical yield. Because if the limiting reagent is already consumed, no more product will be formed. The excess reagent is the substance that remained unreacted after the chemical reaction, or there is a certain amount of that substance that remained unreacted after the chemical reaction. Usually we are asked to get the excess amount, and it is calculated using the formula excess amount equals the initial amount minus the amount that reacted. The amount reacted is related to the theoretical yield, which we can calculate using the process shown here. Let's have an example. In an experiment, 3.25 grams of NH3 are allowed to react with 3.5 grams of O2. Letter A. Which reactant is the limiting reagent? B. How many grams of nitrogen monoxide are formed? C. How much of the excess reactant remains after the reaction? Let us start by balancing the chemical equation, and this is the balanced equation. You apply your knowledge in chemical balancing. The next one, we determine the limiting reagent. We will start with NH3. The idea here is to convert the reactant into one of the products. It's either NO or H2O. But since we are asked also to get the amount of NO formed, we will convert the grams of the reactant to grams of NO. So we'll start by converting this 3.25 grams of NH3 to moles of NH3 using the molar mass, and then the balanced chemical equation ratio. It tells us that 4 moles of NH3 is consumed to produce 4 moles of NO. As you can see, moles of NH3 will cancel. We are aiming for the grams of NO, so we will multiply the molar mass. The units will cancel. We are left with the grams of NO, the desired unit. Simplifying this, we get 5.7263 grams of NO. We are dealing with 3.5 grams of O2 times the molar mass times the balanced chemical equation ratio. 5 moles of oxygen is needed to produce 4 moles of NO. Times the molar mass, we get 2.6256 grams of NO. Now, the reactant that gave the least amount of product is the limiting reagent, because again, once the limiting reagent is consumed, no more products can be formed. The limiting reagent is therefore oxygen. The limiting reagent dictates the amount of products formed. Since oxygen is the limiting reagent, the amount of grams of NO formed is 2.6256 grams, not the amount of NO from NH3 because it's the excess reactant. So again, the excess reactant or reagent is NH3. To be able to calculate the excess amount, we first get the amount reacted. So we will use the theoretical yield. We'll convert 2.6256 grams of NO to grams of NH3. We do that by multiplying grams of NO to its molar mass times the molar mass ratio times the molar mass. We will get 1.4902 grams of NH3. So that is the amount reacted. The excess amount is given by the equation initial minus reacted. The initial amount of NH3 is 3.25 minus the amount reacted, we get 1.7598 grams. Therefore, 1.7598 grams of NH3 remained unreacted after the reaction.